Limits is concerned, as we know, with finding a value that f of x approaches, that we will call L, as x approaches a, any set number. Now, there are times when the limit does not exist, and as such, for some of those times, the limit of f of x as x approaches a is equal to infinity. And we discussed that in a previous video. But suppose we wanted to determine the limit of f of x as x approaches infinity. In other words, we're saying, is there a number that we can say that f of x approaches as we render x larger and larger and larger? In other words, I'm taking x values such as 100, and then I'm taking another x value 1,000. I'm taking another x value 10,000. I'm taking another x value 1,000,000. And I'm saying, when I plug in those values, and I'm getting closer and closer to infinity, I'm just getting larger and larger, does my f of x approach a set number L in the same way? So what am I wanting to find here? I want to find the limit of f of x as x approaches not a, but infinity. So let's look at an example. We have the function 3x squared plus x plus 3 all over x cubed plus 8x plus 9. And we want to find the limit of that function as x approaches infinity. So let's take a look at the graph first of all. So as I said before, we're concerned with finding, by looking at this graph, the value that f of x approaches as x gets larger and larger and larger. Now, looking at this graph here, as x gets larger, we can see that f of x keeps getting lower and lower and lower. In fact, it really and truly is approaching a set number, which we'll come to appreciate algebraically in a few seconds. So, as we said, f of x is approaching a set number as x gets larger and larger. And you can see that the graph here is actually getting closer and closer to the x-axis. What is happening here is that the x-axis is asymptotic, or is an asymptote to this graph right here. And again, what do we mean by that? By the x-axis being a asymptote or an asymptote to this graph here? We're simply saying that this graph here is getting closer and closer and closer to the x-axis, but what? It will never touch it. But we can see from this graph that as x gets larger and larger, since the graph is getting closer and closer to the x-axis, since the x-axis is asymptotic to that graph, then the limit really and truly does exist. But how exactly do we come to find that limit? Let's see. An easy way to find the limit of this function, or like any other function of this nature, is to look for the variable that is being raised to the highest power here. We're going to be picking out the term, or we're going to be looking for the term in this entire function here that has the highest power, the independent variable that has the highest power. In this case, it is x cubed. In other words, we're going to be multiplying the numerator by 1 over x cubed and multiplying the denominator by 1 over x cubed also. And what does that leave us with? That leaves us with the task of finding the limit of 3 over x plus 1 over x squared plus 3 over x cubed all over 1 plus 8 over x squared plus 9 over x cubed as x approaches infinity. Now, to appreciate the final answer that we'll get, you need to come to notice that, alright, let's look at it this way. If I have the number 3, and I divide that by 10, I'm going to be getting 0.3. 3 divided by 1,000, I'll get 0.003. And the fact is, if I keep dividing 3 by larger and larger quantities, if I keep dividing a fixed number by a larger and larger quantity, what will happen? I'll be approaching 0. So the idea here is to take advantage of that fact. The fact that we know by dividing a constant by larger and larger values, we are approaching 0. We're going to be exploiting that fact. So what we're going to do is that it's like we're going to be doing direct substitution. And we're going to be plugging in infinity. So we're going to say, okay, 3 over infinity would give me what? 0. 1 over infinity squared would give me what? 0. 3 over infinity cubed would give me what? 0. All of those are approaching 0, right? What about the denominator? 1 is a constant, and as such, it's approaching itself. 8 over x squared, what's that? That is approaching 0 as x squared, as x approaches infinity. And what about this term? Again, 0. So what does that leave us with? That leaves us with 0 over 1. And as such, we come to the conclusion then that the limit of 3x squared plus x plus 3 all over x cubed plus 8x plus 9 as x approaches infinity is equal to 0.